So today we discuss about the resource management and monitoring. So in this chapter we discuss how can you monitor and manage your resource like your CPU, your memory, your storage input output for the virtual machines. Okay.
Okay.
So in this module we have total 4 lessons. In first lesson we discuss about the virtual CPU and virtual memory concept. The second lesson we discuss about the resource control and resource pools. In third lesson, we discuss about the monitoring the resource uses, and in last chapter we discuss about the alarms. How can you set the alarms? Okay. So in first chapter we discuss about the CPU and memory concepts. So basically memory virtualization basics. So there are some terms that we use like the guest OS virtual memory. So it's a virtual memory and it's a part of your or your RAM or your hard disk that are represented for your applications by your operating system. And the guest OS physical memory is the memory that are assigned by the VM kernel service to a virtual machine. And the host machine memory is the memory that you attached on your host system, and this memory managed by the VM kernel. Okay. So physical memory will be assigned to your your virtual machine, and the guest operating system use that memory and allocate that memory to the applications that are running inside that virtual machine. So virtual memory over commitment. So memory over commitment is when the combined configured memory footprints of all powered on virtual machine exceed that of the host machine size. So if your host has a 16 GB of memory and you assign more than memory to a virtual machine, so that is state known as memory over commitment. So virtual machine do not always use their full allocated memory. Sorry?
No, I was saying that if you assign memory more than the physical memory, it cannot function, or will it function?
No, it will not function. If you assign more than available memory, then the remaining virtual machine will not function. Okay. So if you look in this scenario, the the host is total memory is 4 GB, but you assign the 8 GB memory. Okay. If you start power on those virtual machine, you can start only 2 virtual machine. Okay.
Okay.
You cannot another ones. Okay. So to resolve this issue, memory do not always use their full allocated memory. So if you assign, let's suppose you assign the 2 GB memory to a virtual machine, but every time a virtual machine cannot use their all memory. Okay. So an ESXi host transfer the memory from idle virtual machine to the virtual machine that need more memory to improve their use. Okay.
Okay.
And that memory overhead is stored in the swap files. So we use the memory swapping to store the memory's extra data in swap files. Okay.
Okay.
So like that, you have only 4 GB memory, but you can power on more than 2 machines with 2 GB memory because some of the part of your memory is stored in swap. So this technique is known as memory swapping. And memory reclamation techniques. The memory reclamation occur when the free memory value of the host is 6% or less. So indicating that the host cannot meet the memory requirement. So EXI can use the following methods. So there are 2 methods. One is the economized use of the physical memory page. So transparent page sharing allow the page with identical content to be stored only one time. Another one is deallocation the memory from one virtual machine to another. So bullying mechanism become active when the memory is scarce and force the virtual machine to use their own page areas. So memory compression tries to reclaim some memory performance when the memory contention is high. So host level SSD swapping. So what we do, we attach some SSD hard drives for swap files for better performance. And the page virtual memory out of disk. So using the VM kernel swap space is the last resort because of the poor performance. But if you are using the swapping, it's degrade your performance, but it allow you to run more machines using more memory. Okay. Other one is the multi-core virtual CPUs. So multi-core virtual CPUs support you can control the number of the cores per virtual socket in a virtual machine. So there is a scenario, like in the first scenario, we have a single core CPU, single core dual socket. So if you look, there is two logical processors. So a socket has some cores, a core has some CPU, and a CPU, a logical CPU, and it can run the number of threads and physical scenario. And when you assign the CPU on your virtual machine, you can assign equal or less than your physical available total physical CPUs, physical logical processors, CPUs. Okay, you cannot assign more than available CPUs. And on a single machine, you can assign maximum 128 virtual CPUs. And VM kernel scheduler consider the socket core thread topology when making the scheduling decisions. Intel and AMD have developed the processor that combine the multiple processors core into a single integrated circuits that called a socket in decision. So a socket is a package that can have one or more physical CPUs. So when let's suppose you assign a single CPU to a virtual machine, and you are running three virtual machines on your host, and your host has two CPUs. So total assigned virtual CPUs are 3, but available CPUs is 2. Okay. So basically, when you assign any CPU to a virtual machine, that virtual machine cannot commit that CPU. It just use that CPU to execute their tasks. So it's execute the task on that CPU and free that CPU. If CPU is busy to execute some tasks, so VM kernel scheduler place that new task to least busy CPU. So if logical CPU cannot be completely on by a virtual machine. Benjamin, give me a minute.
Okay.
Hello.
Hello.
Okay, so in perspective of the CPU, we have another like technique is hyperthreading. So basically, hyperthreading allow you to execute two or more threads, two threads, or you can say a set of instructions at the same time. So if your CPU support the hyperthreading, then your CPU behave like two logical CPUs. Okay, so hyperthreading provide more scheduler throughputs, and hyperthreading enabled by default. If your CPU support the hyperthreading, then you can through the BIOS setting, you can enable the hyperthreading on your CPUs. So after enabling the hyperthreading, your logical CPU work like two logical CPUs. For the CPU load balancing, VM kernel balance the processor time to guarantee that the load is spread smoothly across the processor core in a system. So the CPU scheduler can use each logical processors independently to execute the virtual machines, provide capability similar to traditional symmetric multiprocessor systems, and the VM kernel intelligently manage the CPU time to guarantee that the load is spread smoothly across the processors in the core. And every 2 to 40 milliseconds, the VM kernel look to migrate the virtual CPUs from one logical processor to another to keep the balance load. Okay, and VM kernel does it best for schedule the virtual machine with multiple virtual CPUs onto different core rather than two logical processors on the same time. But if necessary, the VM kernel can map two virtual CPUs from the same virtual machine to the thread on the same time. So basically, the VM kernel schedule your task to execute on your logical CPUs. So in this chapter, we discuss about the CPU and memory concept, overcommitment of resource, identify the addition technology to improve your memory like swapping, and for the CPU, you can use the hyperthreading. So in the second lesson, we discuss about the resource control and resource pool. So it's an important lesson. So using the resource control and resource pool, you can manage your resource. You can divide your virtual machines according to the performance and utilizations. So in this chapter, we discuss about the assigning save values for the CPU and memory resource. Discuss how the virtual machines compete for the resource, create a resource pool, set the resource pool attributes, establish the CPU and memory reservation and limitations, and describe the expandable reservation and use a virtual application app to manage the virtual machines. So take a look on this diagram. So the available capacity is the limitation of your resource. Like on your host, you have four logical CPU, and each logical CPU have the 2.4 gigahertz power. So you have total like 9.6 gigahertz. This is your available capacity, or you can say this is your limitation. You cannot use more than this power. One is the resolution, the least amount that can necessary for that virtual machine to start. So that is the resolution. If resolution is not available for a virtual machine, that virtual machine cannot be started. So you can set a resolution, like you can set 0 or any amount of the resolution. Then the save value. After the resolution, the remain Hello.
Yeah, hello.
Yeah, Magesh is joining. I think
Okay.
he getting some issues. He tried to join on order link.
Yeah. Me too. From the I did that, and later I found out that they sent the link on WhatsApp, so I used the WhatsApp link.
Yeah. So let's suppose your total capacity is 9.6 gigahertz, and you provide a resolution on a virtual machine like 600 megahertz. So remaining capacity is your 9 gigahertz. So 9 gigahertz is distributed between the machines based on the shares, like which machine get how many percent of the resource. Okay.
Okay.
Yeah, Magesh has joined. Hello, Magesh.
Yes. Can you hear me?
Yeah. Yeah, I hear
Oh,
you.
awesome.
Okay.
Okay, cool. Yeah.
So
You can continue, please.
we are discussing about the ratios. Okay. So when you assign some resource on a virtual machine, there is a criteria. Let's suppose you have total 9.6 gigahertz CPU. Okay. So this is your available capacity, 9.6. And let's suppose you assign on a virtual machine 600 megahertz reservation. It's mean that machine at least require the 600 megahertz of CPU power to restart. And the remaining resource like the 9.0 gigahertz are shared between the virtual machines based on the percentage, and that percentage value is known as share. Okay.
Okay.
So resolution guarantee that that amount of that amount is guaranteed to provide that virtual machine to start. If that amount of resource is not available for that virtual machine, the machine cannot be boot. So you can define those settings on your virtual machines, on your resource pools, on your vApps. So by simply you can go to edit setting or you can go to edit resource setting. So edit resource setting is available on your vSphere web client. It's not available on your vSphere client. So you can provide those settings using the both methods, using the resource setting or using the edit setting. And on you can assign like those values on CPU, memory, and storage input output. So like the shares, reservations, limits. Okay.
Okay.
Okay, so let's take a look on those values. So now I'm going to open vSphere web client. Okay,
Okay.
so by default on the virtual machine there is no reservation.
Okay.
If we look on our ESXi 1, there is total resource is capacity is 8.38 gigahertz. You can see this is your limit.
Yeah.
Okay.
Yeah.
Similarly, for the memory, 8 GB memory is the capacities. For the memory, this is your limitation. And if we look on the this virtual machine, like right, edit resource settings. You can edit your resource like that, or you can edit your resource using the edit setting. Go to CPU, extend the CPU property, and you can set here like the how much resolution you want to provide in gigahertz or in megahertz. Okay, so by default there is no resolution, 0, and the limit is unlimited, means unlimited how much resource are available there according to this limit. So in our ESXi host we have 8.34 gigahertz. So this is your limitation. Unlimited mean 8.34 gigahertz, and the share value is normal. So according to the normal, share value is 1000, low is 500, high is 2000, and you can also provide some custom value here. Okay. Similarly, you can provide those things on your memory. Okay, like resolutions, limitations, sales, and for the storage, you can provide on your input output, like input output speed. So say value, limitations, and there's okay. So let's take a look on our slide. So you can set the values like this. So first of all, we discuss some scenarios, how those resource settings work. Okay, so let's take a look on this scenario. So here we have some machines like VM1, VMA, VMB, VMC, VMD. So there is a state of your power of virtual machines. Okay, so VMA has 1000 share, VMB has 3000 share, VMD has 1000 share. So at the power on state, you powered on VMA, B, C. VMD is still powered off state. So if we count, the total share is 5000. Okay. Say count only for the powered on virtual machines. Powered on virtual machines share cannot be counted in total value. So the total share is 5000. So if we count, if we calculate the you can say the percentage value of resource for virtual machine A is virtual machine A share is 1000 divided by total share. So total share is 5000. So it's equal approx 1 by 5. You can say it's 20%. So VMA use the 20% of available resource. Similarly, VMC also use the 20% of available resource, and VMB use 60% of available resource. If you powered on your virtual machine D, then total share is 6000. Okay. And now if you calculate for the virtual machine A, the share value is 1 by 6. It's approx 17%. Okay. So the share value define how much resource will be provided for that virtual machine out of total shares. So when you start more and more machines, the percentage will be decreased. Okay. So other term is resource pool. So to manage our resource in a better manner, in a hierarchical manner, we use the resource pools. So resource pool is like a logical abstraction of hierarchical managed CPU and memory resources. So you can create the multiple resource pool inside a cluster or inside a host. And you can also create a resource pool inside a resource pool. Okay. So if we look in this diagram, there is some resource pool like this is your cluster. Inside this cluster, you have a host server. Inside this host, you create a resource pool. So this is your root resource pool. Okay. This is your, you can say this is your host server. This is your root. Inside that, you create some resource pool like resource pool marketing, resource pool QA. So the relationship between those resource pool is sibling relationship. Inside the QA, we create another resource pool is UI. So the relationship between these is parent-child relationship. So it's child resource pool require the resource from their parent pool. Okay. So similarly, virtual machine, you can assign the reservation, limitations, and the share on the resource. Okay. And machines that are running inside the resource pool, they consume the resource from the resource pool. So there are some resource pool attributes. So you can create a child resource pool of any ESXi host, resource pool, or a DRS cluster. And the share values may be low, normal, high, and custom. So the number of the shares for the low is 500, for the normal is 1000, for the high is 2000, or it can be different value. And you can define the resolution for the CPU in megahertz or gigahertz, and for the RAM is MB or in GB. Like the limitation you can assign, like the limitation for the CPU is megahertz and gigahertz, for the memory MB and GB, or unlimited access by default up to the maximum amount of resource capacity available on your host servers or in your cluster. Then this is a important term, resolution type. So there's two type of resolution. One is the expandable or non-expandable. If you check the expandable, like look here, if you check this box, means you are allowed to expand the resolution for this pool. Means pool can expand the resolution according to the requirement. The pool can require the resource from their parent pool or from the host. If you deselect, then this pool cannot require the resource from their parent. And when you are assigning the resolution on the virtual machines that are running on a resource pool is not greater than the resolution of the resource pool. If you assign the more resolution on the virtual machine than the resource pool, and your resolution type is non-expandable, then your virtual machine will not be start. If it's expandable, then your pool can like borrow the resource from their parent to start those machines. Okay. So the expandable selected with the virtual machine and subpool can draw from this pool's parent. And expandable deselect, the virtual machine and subpool can draw only from this pool even if the parent had the free resource. So there is some regions to use the resource pool, like flexible hierarchical organization of your virtual machines, isolation between the pools and sharing in pools, implement the access control and delegation on the resource, separation of the resource from the hardware, management of the set of virtual machines running a multi-tier services like you have some web application servers, some database servers, some application servers. Ability to prioritize your virtual machines workload. So we have some examples. Using those examples, we try to understand the resource pool and the allocations of the resource. So in this example, inside a server, we have a pool, resource pool with the name of engineering pool. And the share value of this engineering pool is 4000. Total resolution is 1000 megahertz. And the limitation is 4000. And the expandable resolution is just, yeah. This pool can borrow the resource from their parent if required. Inside this pool, we have two virtual machines. One is engineering test VM. So this test VM save value is 1000. There is no resolution and limitation is 1000. And for the engineer, the save value is 2000. Resolution is 250 megahertz and limitation is 4000. So let's suppose first of all I'm going to start this test VM. Okay. So according to the test VM, this virtual machine do not have any resolution, so it can be boot with 0 megahertz. After that, it take the resource according to their save value. So we have total resources, let's suppose is 4000 megahertz. And we also starting that production VM is take the 250 megahertz resolution from the pool resolution. Okay. And the sale value of this virtual machine is 2000. So if you look there, the total sale is 3000. If we create the percentage value, so the percentage value of test VM is 1 by 3 and the engineering is 2 by 3. So out of the available ratio, available CPU power, the test VM use the 1 by 3 part and the engineering VM use the 2 by 3 part. So you can say 33% resource test VM can use and the 67% resource a production VM can use. Okay. If we look in this scenario, so there is a dividation of there is two pools. One is the engineering pool, one is the finance pool. So the pool save value of the engineering pool is 4000 and the finance pool is 8000. So total is 12,000. If you calculate the percentage or the percentage value, so for the engineering pool is 4000 divided by 12,000. So it's approx 1 by 3. So you can say 33%. And if you calculate for the finance, it's approx 67%. So engineering pool use the 33% resource of your host server and the finance pool use the 67% of resource of your host server 1, server G1. And inside those pools you have some virtual machines like test VM, engineering test VM and engineering production VM. So the test VM has 1000 share, production VM has 2000 share, so total is 3000. So if you calculate, so test VM use 1 by 3 or you can say 33% and production VM use 2 by 3 means 67%. So you can say the test VM use the 33% of your engineering pool, and engineering pool use the 33% of your host servers resources. Okay, so the resource are divided like that with the help of save values. So you understand how the save values work? Ben, Magus,
Yeah.
Yep.
A bit confusing, but
Ben?
I think I'm getting.
Sorry?
I said it's a bit confusing, but I think I'm getting it little by little.
Okay, so let's look again. Basically, based on the share values, you can divide the resource, which resource pool of the VM use how much resources of available resource. So the ratio of the share value will be count of powered on virtual machines. Okay, or your resource pools. If you look in this diagram, let's suppose your host server has 10 gigahertz of CPU. Okay, and in this host you create two resource pool. One is the engineering, one is the finance, and here is the share value of those. So we calculate the percentage value of each one. So first of all, what we do, we sum of those shares. So the total share is 12,000. Now we calculate for the engineering. So we divide the engineering pool share by the total share. So 4,000, if we divide the 4,000 by 12,000, it's approx 1 by 3. If you calculate it's approx 33%. So it use the 33% of your host service resource. So it's approx 3.3 gigahertz. It consumes the 3.3 gigahertz. Similarly, the finance pool consumes the 67%, so approx 6.7 gigahertz. Now, inside the engineering pool, you have two virtual machines. Basically, a pool cannot consume any resource. A pool have some virtual machines. Those virtual machines consume those resources. So this pool provides the 3.3 gigahertz to those virtual machines. So we have two virtual machines. One is the test, one is the production. The test VM has the 1000 shares. Production VM has 2000 shares. So the total shares is the 3000. If you calculate the percentage scenario, so 33% for the test VM and 67% say for your production VM. It means the test VM use the 33% of 3.3 gigahertz. Okay, it's approx, you can say it's 0.9. Okay, and the 67% is used by the production VM. So it's approx, you can say, calculate that value. What is that or something? It's approx 2.2 or 2.3. Okay, the resource values are divided like that based on the share values. Okay. So if you look in this diagram, so notice how you have two engineering pool. Engineering pool use the 33% and the finance pool use 67%. So similarly, the test VM use the 33% of your engineering pool resource, and engineering pool resource is 33% of total resource. So if you calculate it approx the 11% of all our resource are used by the engineering test VM. Okay. Similarly, you can calculate for the other virtual machines. So VM kernel service schedule those resources for those virtual machines. So this is the CPU contention. Now let's look about the expandable resolution. So Borrowing the resource occur recursively from n sector of the current resource pool. So expandable resolution option must be enabled, and this option offer more flexibility but less protection. So using the expandable, you can borrow the resource from the parents pool. Okay. So if we look in this diagram, the root resource pool has total 10,200 megahertz of CPU and 3000 MB of RAM. Inside that you have a pool with name of retail pool, and the resolution for that retail pool is 3000 megahertz, and the expandable capability is yes. Inside that you have some other pools like e-commerce app pool and e-commerce web pool. So e-commerce app pool has the resolution of 1200 megahertz, expandable is yes, and the e-commerce web pool has a 1000 of resolution and expandable is no. So if we like add both of the resolution is 2200 megahertz, that is less than of the retail pool resolution. So it can it be satisfied. So you can create both pools. So after that, if you create the virtual machine inside the app pool and you are assigning the resolution, it cannot be more than 1200 megahertz. If it's more than 1200 megahertz, then the e-commerce app pool expandable is yes, so it can borrow the resolution resource from their parent pool, from the retail pool. Okay. So we look in detail. So look in this scenario. Here we have a resource pool. This one. First of all, root. There is the total capacity of CPU, total capacity of memory. Inside that you create a pool with retail pool and you assign the resolution of 3000. And expandable is no. So the retail pool cannot borrow the resource from their parent pool. Okay, for the resolution. Now you create two another pool inside this one. One is the app pool, one is the web pool. Okay, in the app pool you assign the 1200 megahertz of resolution, and expandable is yes. And on this pool you assign the 1000 megahertz. So if we check 1200 and 1000 is total 2200. So the remaining resolution on this resource is approx 800. Okay. Now inside this web pool resource, we have three VMs: VM1, VM2, VM3. VM1 has the 400 megahertz resolution. When you powered on, it's reserve that resource. So now available resource on web pool is 600. Okay. Now when you power on VM2, it also 300 resolution. So now available resolution is 300. Now when you start the power on the VM3, the resolution is 500, but this pool has only remaining 300 megahertz for the resolution. So it cannot be satisfy the resolution of this virtual machine. So this virtual machine cannot be powered on because the resolution not satisfied. So this pool is trying to borrow the resource from the parent pool, but expandable is no. So it cannot borrow the resource from their pool, their parent pool. Okay. So you cannot power on this virtual machine. So you need to like reduce the resolution of this virtual machine or increase the resolution of your web pool. If we look in this scenario, okay, so let's start from left side, right side, from this pool. Count how much resolution for this one is 1000. Okay. Give me a minute. Now, let's start with this pool. So the resolution of this pool is 1000. Okay. So first of all, I'm going to start this VM. So when you power on this VM, it's reserved the 400 gigahertz. So now if we minus the 400 megahertz, so now available resolution is 600. Okay. Now I'm going to power on this virtual machine. So it's reserved 300. So if you minus 300, you have only 300 available resolution for other resources. Now I'm going to this power on this VM3. It's required the 500 megahertz resolution, but we have only 300. So we cannot power on this virtual machine. Okay. So it's go to the pool. It's parent pool. The pool look, can I expand my resolution? So here is yes, you can expand. So it's make a request with the parent pool to I need 200 more. Okay. So resource pool, if we look in this resource pool, 1200 is for your app pool and 1000 for your web pool. So total is 2200. Okay. And the resolution of this pool is 3000. So we can say 800 is now is available on this pool. So this pool provides the 200 megahertz of resolution resource to this pool. 200. Now remaining resolution on the parent pool is, if we minus 200, is 600. Okay, and you powered on these ratios. Okay, so all the VMs are started on the web pool. Now we are going into the app pool. I start the VM4. It's require the 500. So the total resolution available on the app pool is 1200. If we minus 500, now available is 700. Okay. I'm going to start this one. It's also require the 500. So if you minus 500, now available is how much? It's 200. Now I'm going to start VN3. It's also require the 500, but on your pool you have only 200 of resolution. So your app will look at the expandable. Yes, I can expand the resource. Just make a request to their parent pool. I need 300 of resolution resource. So it's look in their own resolution. Yeah, I have 600 available resource. So it's provide the 300 to this pool. So remaining resource is 300. And this virtual machine is now powered on and there is 0 remaining. Okay. Now I'm going to start the power on the Windows 7. It's also required the 500. So it's go to the pool. Look, I don't have any resolution resource. Okay, so it's check. Can I expand? Yes, it's look their parent pool. So parent pool check their resolution. So there is only 300, but the pool require the 500. So it's check. Can I expand my resource? Yes, I can expand. So it's make a request to their parent pool. There are so retail pool make a request to the parent pool. I need 200 extra reservation for my child's. So the parent pool, if the reservation is available on the parent pool provide. So parent pool provide the 200 reservation to this ratio to the retail pool. Retail pool add this 200 to their to the available reservation. So total reservation is now a total available reservation is 500 and provide this 500 to their child, and this resource pool provide this reservation to the virtual machine, and your virtual machine will be start. So the reservation and reservation expandable capabilities work like that. Okay.
Okay.
Admission control. So basically admission control is used to ensure that you do not allocate the resources that are not available. So basically when you are creating any, when you are starting any virtual machines or you are creating any pools or you are increasing the resolution of any pool, admission control take the place. It check, it can be expand or not. Okay, the resource can be available or not. So when you are going to power on creating the sub pools with resolution or you are increasing the resolution of a pool. So first of all is check, can this pool satisfy the resolution? Mean, can this pool have the available resolution? If yes, then your operation will be success. If no, then it's check, expandable resolution is enabled or no. If it's not enabled, then your operation will be fail. If it's enable, then it's go to the parent pool and check in the parent pool. Can parent pool satisfy the resolution? Then yes. If yes, then your action will be success. If no, then check expandable resolution. So this thing happen at the root of the tree. Okay.
Okay. So that administration tool is a feature inside the XI host.
Yeah, inside the cluster.
Inside the cluster. Okay.
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 So there is a look of like of your resource pool. So we create our resource pool. So resource pool summary tab display the information that apply to the host machines and its resource. How much resource are available for this pool, how much is utilized, what is the save values, what is the resolution, what is the expandable capabilities, how many machines is running there. Okay.
Okay.
You can check the resource resolution in monitoring tab. How much resolution is consumed by the virtual machines. You can check all those things in the monitoring tab. You can schedule the change to the resource. You can manage the virtual machines with applications with vApps. So basically, vApp is an object in the inventory, similar like your virtual machine or like your resource pool. So a vApp is kind of a container for one or more virtual machines. And vApp can be used to package and manage the multi-tied applications. You can export a vApp in OVA or OVF files. You can deploy a vApp using the OVA or OVF files. You can also set the resource limitation. You can start your own virtual machines inside your vApp at the same time or in a order. You can power off, you can set the network policies. So there are some characteristics of vApp. You can configure the server vApp settings by right click on the vApp like CPU memory allocations, IP allocation policies, and you can also configure the virtual machine startup or shutdown order. Like if you look in this diagram, there is some groups, group 1, group 2, group 3. So shutdown the first group 1 virtual machines power on, after that group 2 virtual machines power on. So you can set here the startup time, like after how many seconds the second group will be initiate their startup. Similarly, you can set the shutdown after how many seconds the next group initiate the shutdown operation. You can deploy and export in OVA and OVF format. So we have a lab to manage the resource pool. So in this lab, first of all, we create the CPU contention, then we create a resource pool, then we verify the resource pool functionality. Okay. So launch your labs. Magesh, launch your lab.
Hi, evening today evening. See, yesterday
Yeah.
and day before yesterday, I got actually stuck with office issue. So there was a major, issue in our data center. So I
Okay.
couldn't do the lab. So today I tried at
Okay.
before training, 2 hours before I wanted to finish all the labs. I tried, but I was
Okay.
getting share my screen that 503 error. I continuously
Yeah.
try. Let me share. Can you give me the permission?
Yeah. Wait a minute. Yeah. Share your screen.
I tried in different browser. Still, it was not. Learning. I think I closed it.
Yeah. Look at the right side. You can launch a lab. At the yeah, this one. Oh,
It is going somewhere else. Let me.
No, no, one second. Scroll down. Select the dashboard. Select the dashboard. On top. Go to top. On the left side, select the dashboard. Go to top. Click the lab. And yeah. Continue. Where you are getting the
I'll show you. Here, when I launch here, I was getting 503 error. That 503.
yeah, basically your vCenter server takes some time to properly start. It takes the 10 minutes. So launch your lab, wait at least 10 minutes, then start your tasks.
Yeah, see,
Like
this is what the error I was getting for 1 hour, not 10 minutes. I waited even 1 hour.
Okay, let's
Sometimes
just leave it. Just leave it. I'm going to start my lab. After my lab, you start your lab, and then we check you are getting the issue or not. Okay.
Yeah.
You complete the migration.
No, that's what I wanted to do it.
Okay.
That's why I logged in, but I couldn't do it. Sometimes the lab is really frustrating. Whenever I try, I'll get this kind of error.
Yeah. Sometimes it's frustrating, very slow, very, but
Basically, it's normally it's take the time. 10 at least 10 minutes. Basically, vCenter is a heavy service, so it's take at least 10 to 15 minutes to properly start. Okay, so I'm going to share my screen and we start our lab.
Okay.
So according to our lab, first of all, we create the CPU contention. Means we run some scripts on our virtual machines, and that script execute the millions of instructions on the virtual machine, and so that the virtual machine require the more resource. Okay. When the virtual machine is requiring the more resource, that state known as the resource contention. Okay. Like if it's require the more CPU, it's CPU contention. If it's require the more memory, it's memory contention. So first of all, we create the CPU contention. So we log in on our web client. Look there.
Yeah.
For this lab, open the web client, not vSphere client, vSphere web client. Log in, go to your web servers, power on the 10.2 and 10.4. So I'm going to power on both machines. Power on 10.2 and 10.4. And make sure both machines are running on the same host servers. So let's take a look. So this machine is running on ESXi 1, good. This is also running on the ESXi 1, good. Okay, make sure both machines are running on the same host. If those machines are not running, so using the migrate vMotion, move your virtual machines on the same host. Now what we do, we run that CPU busy file that we copied on our desktop. So I'm going to launch the console, web console, continue. Oh, trust relationship issue with Windows 10 too. I'm just going to restart this machine. So I'm going to fix that trust relationship issue. Okay. It's not a part of our lab. It's taking so much time. Okay, so I'm going to run this CPU BG file. So right click and open with command prompt and take about the times. So I did 3 million cents in 0 seconds. So it's approx executing the 3 million instructions within the 0 seconds. Okay, and we do the same thing on Windows 10 too. It's also executing the same instructions within the 1 or 0 seconds. Okay, so wait few minutes to analyze the records. Like at the starting of your computer, some of services are consume the resource, so it's taking 1 second. Otherwise, it's look there. It's also executing the task in 0 seconds or 1 seconds. Okay, they are requiring the more resource. If you look in here, the resource utilization. So Windows 10 to utilize approx 2.1 gigahertz resource, and 10.4 also utilize approx same resource. Okay, CPU. Look there, it's also executing in 0 seconds. Now what we do, we create a resource pool. We create two resource pool with different share values, and we assign those virtual machine to those resource pool. Then we check it again. What is the difference to execute those 3 million seconds? How much time take they will require to execute this instruction. So I'm going to create a resource pool. So first of all, I'm going to just enable the CPU infinity. So both machines execute their task on the same CPU. They cannot change their CPUs based on the load. Okay, to analyze the change. So I'm going to vCenter server, right click, setting, CPU, and enable. To enable, place 1 here in the CPU infinity. Okay, I'm going to do the same thing with 10.4. So look, both machines are taking 1 second. Okay, 1 or 2 second. Now I'm going to create two resource pool. One is the test, one is the production. So first of all, I'm going to create the resource pool test on ESXi 1 because of both machines are running on ESXi 1. So go to host and cluster, right click on ESXi 1 and create a new resource pool. And name of your resource pool is RP test. And the save value will be the low. You can assign your resolution here. You can allow the resolution capability expandable or no from here. So leave other settings default. Just change the save value. Create another one, production. RP products, and here I'm going to assign the save value high. Okay, now I'm going to move those machines in these pools. So move Windows 10 to in production and 10 for in test. Now, if we analyze the change between those machines, so look there, Windows 10 to executing those instructions within a seconds, but Windows 10 4 taking more time, 2, 3, 4 seconds to execute those instructions. Okay, if you check the utilization, Windows 10 to taking the 1.5 gigahertz ratios, 10 for taking the 1.03 gigahertz ratios. Okay, and 10 for taking more time to execute those instructions. Okay, now I'm going to change the save value of test ratios pool. If you want to check the resolution and other things, you can check from here, like how many machines are running and other things. If you check the resolution, you can find inside the ratios resolution. CPU, so Windows 10 for resolution is 0, limitation is unlimited, type is fixed. Okay, so I'm going to increase the save value, so ratios edit setting. I'm going to change from low to normal. Okay, now let's check. Okay, so like that, using the save value, you can assign, like you can provide the more percentage on your available resources. Look there. Now the Windows 10 for executing those instructions within a seconds.
Yeah.
Okay. I'm also changing the save value of production high to normal. It's also taking the 1 minute to execute those instructions. So both are taking same times. Okay. I'm just closing those scripts. Okay.
Okay.
Our next lesson is about resource monitoring. Okay. So complete this lab, then we will move forward.
Okay.
Okay. Magesh, share your screen. start your lab. So you have 20 minutes to complete this lab. Okay, save your screen. Hello, Magesh? Hello, Magesh? Am I audible?
Oh, sorry, I was on mute. Sorry.
Huh. Yeah, try to refresh this one.
I did multiple times. I did.
Still getting same issue? No, now it's working.
Finally. Finally.
Yeah, it's take time.
No, seriously frustrating in a way. It is.
Yeah, look, if it's getting more than 15 minutes, so you can reboot your vCenter server, okay, from the
Okay.
console. If it's getting more than 15 minutes, usually it's take 10 to 15 minutes usually. But if getting more than time, it's taking more than 15 to 20 minutes, then try to reboot. Okay.
Okay.
So follow your lab manual and complete this task.
Yeah.
Okay.
Yeah, sure.
So I will be back on 4 o'clock.
Okay.
Okay.
Ben, we have that CPU-BC file on 02, 04 machine.
Please come again. Come again.
Do you have that file on the 04?
Yeah, yeah.
The CPU-BC file.
Yeah, yeah.
But I'm not able to see that file.
Yeah, I have the file.
No, on 02 it is
That
there.
means you need to
On
open.
Windows-
Yeah. 04, it needs to be there. It needs to be there, 04. If it's not there, then you need to go to the what do you call it, VMware tools. Open the what do you call it, the Windows 4, then go to this PC, open the CD, the DVD icon. That's the DVD icon. Where I think you are sharing your screen. Let me see if your let me see the screen.
Yeah, in the DVD icon.
No, the DVD icon. This PC.
Yeah.
Okay, the DVD icon. Right click, open it. Open. That's right. That means that you have not installed. There's no installation of what do you call it? Then we need to go back to the Windows client. Go back to the desktop where, yeah, that one. Yeah, right click it, and see what's guest opening, guest OS. Install VMware tools something.
No, it's all grayed out.
Is there install is grayed out. No, it's grayed out. Then open again the window. No, you open Windows 3. Oh, Windows 4. View guys user man. Okay, still is grayed out. So just open Windows 4. Open Windows 4 again. Open the web console. Open console. Okay,
Yeah.
try to close it. Try to close this one. Yeah, try to close it. Go to the where the arrow key is and see whether is the down where the normally programs are installed. You can see, yeah, that side. Check and see. Yeah, check and see if it is there. It is there. Yeah, it is there. Open. Just right click, open. No, right click it and open.
No, only these three are there.
Okay. Then go back to open the what do you call it, the DVD. The DVD for my PC. Yeah, yeah. Okay. This PC.
No CD. If it's there, something will be showing here.
Yeah, that's where it will show you. Okay, it's not inserted. Because that's where it will show you the files, so that you can put it on the Windows. You understand? That's where it needs to show you.
Okay. Is it related to previous lab? If we do previous lab only, will it?
Yeah, it's related. It's related to the previous lab. So maybe if you have not done the previous lab, that's why you can't see it.
No, I didn't do this one, managing virtual machine. I didn't do this lab.
Yeah, then I
But
think that's why. Yeah, because there is a process also there that you can use to that you need to add it to the desktop.
oh, okay.
Yeah, there's a process there. There's a process there that you need to add it to the desktop. So maybe you skip that one. That's why you are facing these issues. Maybe go back.
Oh, okay.
Yeah,
Let me do the previous lab. I'll
yeah.
do
Then
this lab then.
yeah, do the previous lab. Then later you do. Because if not, you will not get it that icon.
Okay, okay.
Yeah.
Sure. Yeah. Thank you, Ben. Thank you. Yeah.
No problem.
No, F folder does not exist. Then
Hello, Magesh. What happened? Hello.
I'm not able to see that one, that CPU busy file, that file in 04. I think that is because my previous lab was not done right. That's why. So I am doing the previous one
Okay. On which machine?
on 04.
Okay. Connect your machine first of all. Connect to the console. Yeah. Look there. 1 minute. 1 minute. 1 minute. 1 minute. 1 minute. Look there. 2 and 4 are running on different host servers.
Yeah.
Okay. So first of all, migrate the 2 to host 1. Sorry, 4 to host 1. Expand the host and cluster. Select host 2. Sorry, host 1. Host 1. Resource. First one. Yeah. Next. Okay. Finish.
There is a refresh.
Look at the bottom. It's reallocating.
Yeah.
Look at the task, recent task. Yeah. Now it's completed. Now connect to the console.
See, I can see that file.
Okay. Go to machine setting in vCenter. In vCenter. Oh, yeah. Here. Right click on your machine.
Yeah.
Setting. CD. Yeah. Data store ISO. Class data store. Wait a minute. Select the last file on middle tab. Select the class data store on the top. In the middle panel, look last file. Yeah, this one. Okay. Click on that connect button. Okay. Now go to machine console. Look at that. Oh, it's already open. Open the CD. Yeah. Copy that class BG file. Yeah, on your desktop. Just drag and drop, or you can copy paste.
This one or this one? CPU.
Yeah, third one. Remove the CD. Yeah, execute first. First execute this one. Open with CMD. Yeah. And remove the CD from machine.
Yeah. In the meanwhile, I'll open this console. So we have to do this one.
Not from here, from the setting. Go to machine setting.
Just
Click
unconnect.
on the title ISO and select client device. Okay. Now follow the line manuals. You set the CPU infinity? You have set?
No.
Set your CPU infinity. So go to the setting on your machine.
02 or 04?
Yeah.
Yeah.
Expand the CPU. Type 1 in schedule affinity. Look at the last. Type 1 here.
What should I type?
Number 1. Okay. Okay. Do the same
Why
thing
am
with
I
this.
here?
Yeah, basically, I think it's getting some warning on like last reboot or some unregistered. So reset again. Yeah. Do the same
Okay.
thing on other machine. Do the same thing on other machine.
So should I name 2 here or 1?
No, one. We are using one CPU, so we need to set 1. Okay. Now you need to create 2 resource pool according to your task 2. So follow task 2. Look there. Right click on ESXi. Not.
Yeah. New resource pool.
Yeah, I will be back in 5 minutes. Okay. So follow this manual.
Yeah.
Hello?
Yeah, hello.
Yeah, it's complete. Ben?
Yeah, now I am at lab 40 monitoring virtual machine performance.
Okay, we will discuss it later.
Okay, okay.
Okay. And
Done.
Magesh?
Yeah, done.
Done?
Yeah.
Okay. So we start the monitoring.
Okay.
I'm sharing my screen. So our third lesson is monitoring the resource uses. So how can you monitor the utilizations of your resource on your host, on your clusters, or on your virtual machines? We discuss in this chapter which kind of the tools available to monitor the resource. So you can monitor the resource utilizations inside the virtual machine, like using your guest operating systems tool. Some tools also available on your vCenter, or some tools also available in your ESXi host. And we also some commands to monitor your resource utilization. So basically, based on the resource utilization, we can identify which kind of the contents, like CPU contention or memory contention happening or not. So if any CPU contention or memory contention happening, then we need to like allocate more resource, or we need to identify the applications running on your virtual machine that are creating the contention of resources. Okay.
Okay.
So in this chapter, we use the performance tuning methods and resource monitoring tools. Use the performance chart to view and improve the performance, and monitor the key factors that can affect the virtual machine's performance, like CPU, memory, disk, and network bandwidth use. So performance tuning methods. So follow the best practice for performance tuning your vSphere infrastructures, like assess the performance using appropriate monitoring tools, record a numerical benchmark before the change, identify the limiting resource, which resource limiting your performance, then make more resource available, allocate more resource, like reduce your competitions and log your change, then create the benchmark again. So there are various monitoring tools, like inside the operating system. We have the performance task manager, and outside your guest operating system in vCenter, we have the vCenter server performance chart. vRealize operation manager, a separate tool that you use to monitor your resources and resource utilizations for your vSphere and ESXi system logs. And we have some commands like restop on your ESX on your vSphere, and ESX stop on your ESXi servers. So these are these two commands. So you know how to monitor the resources in the task manager. So I'm not going to discuss about the task manager and performance monitor. Here we are discuss about the vSphere performance chart. Okay. So first of all, we look using the EXTOP to monitor the VM resources. So basically, it's a command line tool. You can execute this command using your ESXi SAM, ESXTOP. Similarly, we have another command is RS ESXTOP. You can execute this command on your vCenter uh, command line interface. Okay, so basically ESXTOP work like a top command in your Linux. So basically, top command is like your task manager in Linux. So we use ESX is a kind of similar like top. So here we look how to execute that command and how can you monitor the resource. So here I'm going to execute this command. So I'm going to my lab. Oh. I'm going to open that putty. Give me a minute. So I'm going to open this putty, and here there are some sessions are already created on this. So I'm going to select this ESX one. Okay. Now I am inside the ESX terminal. So I'm going to execute that ESX stop command. So look there, with the complete CPU memory and utilizations and other for your virtual machines and other processes that are running inside your ESX host. If we check here, look at the first line. It's about the Windows 10 too. The used is 83.79%. Okay. And this is the runtime, like similarly wait time. Okay. And this is your other machine that I use time is 1.33%. So Windows 10 to using so much resources. Let's check inside the operating system. Some applications utilize this Windows module installer. So like that, you can identify which resource, which process is utilizing the resource. If I go, if I like, and this, now your resource utilization is less. So if you look in terminal, look there, Windows 10 to use is approx 19 or 14%. Okay, so you can check like that. Okay, I'm going to just stop by pressing the Q button. Using the Q button, you can exit from your xstop command. So the main tool is this performance chart. So vSphere statics subsystem collects data on the resource use of the inventory objects like counter and matrix group, like which kind of things you want to monitor, collection levels and collection intervals, like in which time interval you want to collect the samples, and the data availability, like how much old data samples you want to check. So this is your overview of your performance chart, like you can check your CPU, your memory. Okay. So these are some components on your performance chart, like here you can choose your chart option, you can choose your counters, roll up statics. Here your statics matrix, like what you want to monitor, like you want to monitor the CPU or you want to monitor the like memory disk. So you can select here your chart matrix. You can choose the time span. You want to check the real-time statics, last day, last hour, last week, last month, last year statics. Here your objects, which objects you want to monitor, like one ESXi, both ESXi, or other components that are running inside the ESXi, like virtual machines. And chart type, you want to check in line graph, in pie graph, in star graph. Okay. So there is like chart options. So these are chart options, like you can check in real time. So the samples of every 20 seconds, and the number of available samples will be 180. If you select the past day, the samples will for every 5 minutes, and total samples will be 288. So like that, you have the statics. You can choose any type of the chart option. Then chart type, you can choose the line graph, line chart, bar chart, pie chart, stock chart. You save your chart in CSV format or any PNG or JPG image format. You can choose your counters, like if you want to monitor the CPU, so which CPU you want to monitor. If you have the multiple CPUs, so you can select your CPUs. If you are going to monitor the disks, so you can select any specific disk based on the runtime name. Similarly for the NIC cards, you can select your statics, in which rate you want to monitor, in for the CPU in megahertz or in gigahertz. For the delta, for your CPU interval time, like CPU ready time, waiting times, like that. Roll up is the conversation function between the statics interval. So 5 minutes of past hour statics are converted to 1 day value. So basically, your running time data will be stored and it will be converted in historical data after some time. Okay,
Okay.
like average or some. Integration. So vCenter, server monitoring tool, and guest operating system monitoring tools provide a different point of views. Like we have the different monitoring tools to monitor your resources with different point of view. Now there are some terms like CPU constraints VM. So if CPU usage is continuously high, the virtual machines constrained by the CPU, and how the high might have enough CPU for other virtual machine to run. So multiple virtual machines are constrained by the CPU if the following conditions are present, like CPU uses high in the best operating system and relative CPU ready value for the virtual machine. So if your CPU value, use is high and relative high CPU ready means CPU concentrants is there. Like, similarly for the memory, if boolean activity is high, and this state might not be problem if virtual machine have the sufficient memory. If boolean activity is high and the guest OS is swapping, if swapping is happening with high boolean activities, means that is memory concentrated with the virtual machine. Okay, monitoring the VM activities, so you can monitor the VM monitor for increase in the active memory on the host. Host activity memory is active physical memory used by the virtual machine and VM kernel. If amount of active memory is high, the virtual machines might become memory concentrates. Disk concentrates. So disk intensive applications can situate the storage or the path. So if you suspect that the virtual machine is concentrating by the disk access, measure the throughput and latency between the virtual machine and storage. Use some advanced performance chart to monitor like read rate, write rate, read latency, and write latencies. So to determine the disk performance problem, monitor two disk latency counters like kernel command latency. This counter is the average time span in the VM kernel service per SCSI command. So high number is greater than 2 or 3 milliseconds represent either an overload array or an overworked host. Physical device command latency. This counter is average time with physical disk take to complete a SCSI command. So high number, if it is greater than 15 to 20 milliseconds, represent a slow or overworked arrays. Similarly, like network constraints like the WAN link between the server and client. So if you suspect the virtual machine constrained by the network, verify that VMware tool is installed and the enhanced network driver are available only if the VMware tool is installed. So measure the effective bandwidth between your virtual machines and its peer system, and check the dropped packets, dropped, received, and transmit packet states. So here we have a lab. So in this lab, we create the CPU workload. We use the performance chart to monitor the CPU utilization and undo the changes made to the virtual machines. So I'm going to my lab. So first of all, we create the CPU load. So to create the CPU load, we similarly run that BG file. Okay, on both machines. So I'm going to run this BG file on both 10 and 4 machine. Now we are going to monitor the loads using the performance chart. So we are going to our vCenter server, select our Windows 10.2 machine, go to monitor here, inside the monitor we select performance and click on advanced. So you can find the chart here. Look there, this one. So here we are going to do some modifications in this chart. So first of all, select your chart option. In the chart option, we select some components, like in the chart matrix, we select CPU. In the time span, we select real time. In the chart object, we select only Windows 10.2. So deselect the window. Okay, we are going to check overall. Okay, all objects. Then in the counter, we click on none. Then we just select some specific counters. So none. Okay. We select the CPU ready time here and used. So check ready and used. Used. Okay. So look there, all the instances are there. So ready time is represented by this black line, and the use is represented by that red line. So how much your CPU is ready and how much is used. So if you look there, the use is high, red is low there. But if we look here, this is a real time here. So ready and use is approx equal. Okay. So if you check the difference between them, it's approx 300 milliseconds. So like that you can monitor. So and we are going to do the same thing on 10.4. Okay, so here is here is some usage percentage. So you can also manage this one like CPU ready and used. So there is a usage in megahertz. So if you look here, the usage in megahertz approx 1033, approx 1000 megahertz usage of your CPU. So like that, you can monitor your resources. Okay, using this chart. If you want to monitor the memory, you can change your CPU matrix like memory. Like I want to check the active memory, Boolean memory, and swap. Swap in rate. So if we look there, the swap is represented by the green. So there is no swap lines. It's approx kind of 0 KB is swapping. Okay, means there is no memory consumption. If swap is high, then you can say the memory consumption is happening there. So here I'm going to stop that CPU busy. Now let's try to monitor the CPU consumption. So wait few seconds and you can find the CPU consumption is going low. Look there. Now graph is going down. Okay. Now we are going to revert the change that we made on Windows 10 to and 10.4. So what we need to do, and we remove the CPU infinity and shut down your machines. So right click on your machine, edit setting, and to remove the CPU infinity, clear this box. Do the same thing on this machine, CPU infinity, sorry, edit setting. Sorry. Okay. So complete this lab, then we go for alarms. Magesh, share your screen.
You can see my screen. Naveen? Hello?
Hello. Sorry, I was on mute.
Okay. Yeah,
Yeah.
I think Naveen is not there.
Maybe he has gone on break.
Your voice is very low, Ben. Very, very low.
Can you hear me now?
Yeah, now it is okay. So where is the option to select this one? Verify CPU is selected in the characters. Now I'm in the map, in the graph.
Okay. Yeah.
Where is this?
Yeah, chat option. Go up where the graphic, yeah, up.
Oh,
chat
I need to
options.
click this.
Oh,
Is it? Okay.
yeah.
Okay, got it. Yeah.
Oh, okay.
Thank you, Ben.
No problem. No problem.
What is this option in the click home icon? Open a new tab, the step 10.
Okay, open a new tab. Yeah, that means we should open a new tab
I
in
can't see that.
the
vSphere web.
Mozilla. Yeah,
Yeah.
then click the vSphere site and click the web. Yeah, the web client. Yeah, the web client. Yeah, to open a new. Okay.
Oh, this one is it? Okay.
Yeah. So now you go to the home icon and the VMware template.
Why we have to open this one? Already we have this one, right? Why?
Yeah, that's what I mean myself. So I was also saying the same thing. Maybe they want to keep the chat. You know, we have already opened a chat, so maybe because of the chat. Understand?
Oh, okay.
Because there was a chat when we did. Yeah, because of the chat. So maybe we are going to do a different thing on the other side.
Okay.
Yeah.
Okay, now record the current CPU ready value. Current CPU ready value. Where is that? Current CPU ready value.
Is it done?
Yeah.
Ben? Benjamin?
Yeah, I'm going. Yeah, I'm going through the questions and they're asking. But if it's not necessary, we can go on. Now I'm page 92, task 3 on undo changes made to the virtual machines.
Okay, make that sense.
Okay, we're going to go to using alarms.
Okay. So we start.
Yeah, we can start.
Okay. So our last lesson of this module is alarms. So basically, alarms is used to like provide any notifications when any incident perform, like any specific event occur or any specific condition occur. Okay. Let's suppose your machine's CPU utilization goes high, so it generate an alarm. Your data store overcommitted, it generate an alarm. So sometimes what happen, we want to generate an alarm for any specific event, so we create some custom alarms. So there are two type of the alarms. One is condition based alarms and one is event based alarms. Okay, so in this chapter we discuss condition based triggers and event based triggers, basically alarms, and view and acknowledge the triggered alarms. So an alarm is a notification that occur in response to a selected event or conditions that occur with an object in your inventory. So default alarms exist for various inventory objects. Many default alarms are defined for host or your virtual machines. So you can create the alarms for following inventory objects, like you can create the alarm for virtual machines, for hosts, for the clusters, for data center, data store clusters, network, distributed switch, and distributed port groups. Okay, there is no alarm for standard switch. So you can to monitor your environment, you can create and modify the alarm definitions in vSphere web client.
Hello?
You can set the triggers when your alarm will be triggered, like a condition based alarm, like when your snapshot is above the 2 GB, or your CPU utilization is more than 90%, or any specific amount, or when your data host is collected, or so many more. So, and you can create the alarms when any specific event trigger, like health of your host hardware has changed, license has expired, any host left your distributed switch or your clusters, like that. You can set the conditions, like, okay, you can configure the events to monitor the current state of host or virtual machines or data store. Configure the action, which kind of the actions you want to perform. You want to generate an alarm, you want to send an email, or you want to perform some other specific event action, sorry. Okay, if you want to configure the mail, if any alarm generated in your center, it will send to the email on the vSphere administrators. You can set up the mail server. Yeah, like you can set up your mail, or you can use the SNMP to forward the notifications to the mail or SNMP. You can check your like triggered alarms, which alarms has been triggered. So after resolving that issue, you can like reset to green, and there is an option like acknowledge. So acknowledge is prevent to generate that alarm multiple times. Okay, so if any alarm generate, administrators acknowledge that alarm, means that administrator working on that issue. Okay, so in this lab we create a condition based alarm, we create event based alarm, we trigger the virtual machines alarms and acknowledge those alarms and disable the virtual machine alarms. Okay, so this is the end of this lesson. The next lesson about the HA, so we'll discuss it later. So we are going to configure the alarms. So first of all, we create a condition based alarm. Okay, so first task is create a virtual machine alarm to monitor the condition. So we are going to create an alarm for virtual machine on a specific condition. So go to your web client, select the machine in your inventory object. So we are going to create an alarm on Windows 10 2. Okay, so right click on Windows 10 2, select the alarm, new notification. Okay, new alarm definition. So here we are going to create a new alarm definition. In the name of alarm, right, like VM CPU uses, VM CPU uses CPU uses for Win 10.02. Okay, next. So here we select the specific condition or state. For example, CPU. So we are going to create a condition-based alarm. If you are going to create a like event-based alarm, select here. And what we are going to monitor, we are going to monitor the virtual machine. Okay. Next. Here you need to define the trigger when that this alarm will be trigger. So click on this plus icon and here select VM CPU usage. And the operator is above and set the criteria according like create a warning condition is like more than 50% for 30 seconds. So edit this one, double click 50% for 30 seconds. Okay. If your CPU usage goes 30%, it's generate a warning. If your CPU usage goes 75% for 5 minutes, it's generate a, so type here 75% for 5 minutes is generate a critical error. Okay, next. Then what action you want to define? Sorry? In the action, I want to define when the CPU usage goes high, the machine will be suspend. Will be going suspend state. So suspend VM and select the other ones when your goes green to yellow. And here we are going to select none. Okay, so when your state means when your machine go generate alarm, warning alarm is goes in suspend state. Okay, if you want to when your machine's state goes from warning to critical, goes suspend, select this one. Okay, I want to suspend the machine when it goes to is generate a warning. So I select good to warning once is suspend for once time. Finish. And other will be blank. Finish. So when your CPU utilization goes high, for 30 goes more than 50% for 30 seconds, your machine will be suspended. Okay. Now let's check this alarm is created or not. So go to monitor, issues, and look at alarm definition. So you can find your alarm here. So we create this alarm only for this Windows 10 2 machine. Where is our alarm? Our alarm is here. Okay. These are other ones are the default alarms that are inherited from your vCenter server. Look, this is the enabled. Okay. You can find your triggered alarms here. Okay. Now we are going to create another alarm based on the events. When your virtual machine state goes in suspend state, it will generate another alarm. So right click on, like, we are going to right click on our data center. So this alarm will be generated at the data center level, like alarm, new definition. We create an event-based alarm, and the alarm name will be VM suspend 2. Okay. Next, in the trigger, click on that add button. In the event, not in the condition, in the event diagram, and select here VM name. Okay, select the VM suspend here. VM suspend, and here the alert. There is no condition. Okay, and here is the condition. Like, this condition will occur when the VM name, when this VM name equal to, what is our VM name? It's case sensitive. It's Win10.2. Win10-02. Okay, it's case sensitive. So this is our condition. Next, it's detect when you VM suspend. Which VM? This VM goes suspend, is generate alarm. Next, if you want to specify any action, no, we do not specify any action. Finish. So you can find your an alarm definition. Where is alarm? Yes. VM. Yes. Here's your alarm. Okay. Now we are going to create some environment to generate this alarm. So what we do, I'm going to run that CPU busy file on Windows 10 to increase the CPU utilization so that this alarm will be initiate. Okay. So go to Windows 10 to run. Let's check what is the CPU utilization. So at this time the CPU utilization is 38%. So I'm going to run this. So when you run this script, the CPU utilization is suddenly goes high. Look at that, the CPU utilization is now 99%. And after 30 seconds, it will generate an alarm. If we look here, there is no triggered alarm yet. So we'll wait few seconds. And your virtual machine goes in suspend state. Look there is a warning message.
Yeah.
You can also find your this message in monitor triggered alarm, like CPU uses. It's a warning. Okay.
Oh,
And your virtual machine goes in suspended states. Look there. It's break.
yeah.
Okay. Now it's red. It generate another alarm for critical. Like look there, the VM suspended. Windows 10 too. Okay.
Okay.
Look there is pause button because your machine is in suspended state. We can also find this thing in event, task at events. Look there, machine is suspended. Now I'm going to power this machine it again. Power on. And we stop that CPU busy file. Okay. Now your CPU utilization is less. Shut down your machine. Okay.
Okay.
Now we disable the alarm. So to disable the alarm, right click on select your machine, go to issue, select alarm and definition, and find your alarm. So here is alarm. Windows CPU busy. Select this one, click on edit and uncheck this. Finish. Okay. Now this alarm has been disabled. Okay. Similarly, disable that we create on our data center. Alarm definition, VM, suspend, edit. Like that you can disable your alarm. Okay.
Okay.
Let's so this is our alarm chapter. Okay. Now let's check the assessment of this chapter. So Magesh, share your screen with us. Go to assessment, chapter assessment, chapter number 8.
No, where is it?
On demand content.
I'm in the wrong page. Wait.
Yeah, go to dashboard.
I'm in dashboard only.
Okay, so click on the first one. What is the first one?
That is lab.
I don't think it's lab. I don't think. Yeah, this is your assessment.
Seventh and final lesson.
So what is the first question?
If the performance chart is displaying the active host levels swapping is occurring.
So what is the issue?
Read latency and write latency. Guest was swapping the host memory is working. The performance chart is displaying the active host levels swapping. Maybe read latency and write latency is high.
No, host memory over commitment. When the swapping goes high, when virtual machines like consuming more memory, at that time the swapping goes high.
Okay. Yeah, the reservation specifies a guaranteed minimum allocation for resource for virtual machine, upper bound for CPU memories, the relative priority importance, or keep track changes on each deployed. Reservation specific.
Yeah, first one is correct. Guarantee that the minimum allocation for that virtual machine.
Okay. Which topology is used by VM kernel scheduler when making scheduling decision? So
Socket core thread.
Yeah. What are the distribution formats of vApp? PDI, VMK, OVF, this one and this one, right?
Right.
Which action can be specified when a predefined alarm does not address the condition state or even that you want to monitor? Which action specified when a predefined alarm? Okay, enable the resource schedule, define custom, modify the predefined. I think modify the predefined alarm.
No, you cannot modify the predefined alarms.
Oh,
So you
okay,
need to
that's
create some
a
custom
default
alarm.
one.
Yeah.
Okay.
Define a new custom alarm. Okay.
Yeah. Oh, what is that?
Yeah, define the custom alarm. Yes, correct.
Okay. Which performance monitoring tool that allows you to point a data point and displays details about the specific data point? Advanced chart supports data counters that are not supported performance charts. Okay, overview performance. Is this one?
First one, the advanced option of your chart, performance chart.
A root resource pool is a standalone host name with 1 CPU and 4 GB of RAM. It has 3 child resource pool attached to A, B, C with equal share value. The virtual machine in each child resource pool are 50, 75, 100. Which child resource pool gets the resource allocated on priority? Okay. Equal across this. I don't know which one.
Yeah, basically, look, it's saying you have a server 001 has 12 handle of CPU and 4 GB of memory. Inside this CPU, you have 3 child pools, means you have 3 pools A, B, C with equal shares. So basically, all three pools get the equal amount of CPU and memory. Okay, and inside each pool you have a virtual machine, and each virtual machine, like first machine have the 50 second has 75 share, third has the 100 share. So basically, if the first machine is inside the A pool, so A pool has a 33% on total resources, and inside the A pool you have a single machine, and the share of that machine is 50, and total share also 50. So you can say it's consumed the 100% of pool A resource. Similarly, in the B and C, so you can say equal across 3 child resource pool.
Okay, so then which is yeah. Okay. Okay. What is virtual machine memory overcommitment? Memory is overcommitted when the combined configured memory of all virtual machine exceeds host memory size. Memory is overcommitted when the combined memory of all virtual memory the virtual machine loads low parents will fail. Virtual machine cannot be overcommitted. Yeah, it cannot be overcommitted, right?
No, virtual machine memory can be overcommitted.
Oh.
Can be. So the right option in A or B. So tell me which one is the right.
Combined memory of virtual machine exceeds the host memory.
No, memory documented no memory power. The host memory sizes. Yeah,
I think all powered on virtual machine.
Yeah, right. Yeah, memory and resource allowed when you power on a virtual machine.
Correct. Yeah. On which vSphere inventory objects can be allowed be used? To choose 3. Okay. Data center. Standard.
Yes.
No, on the standard you cannot.
Okay, then these 3.
Yeah, on data center, on your cluster, on your virtual machines, on your data store, on your distributed switch, on your distributed port groups, you can set the alarms.
Okay. Why is creating a resource pool a good choice for managing resource across cluster? Okay, why?
So it's multiple choice. Yeah.
No,
it's multiple choice question.
Yeah. So resource pools are used to delegate privileges to other users. No. Resource pools can be used in partition available CPU and memory resource. I think C.
You need to choose multiple options. You can choose the multiple options here.
And then everything.
No. Not all. which one is correct? According to you, which one is correct? Read it carefully.
Resource pools are used to delegate privileges now. Example, CPU memory storage that can be allocated. Specify an upper bound for CPU.
Maybe A and C.
I think A and C, or sorry, B and
no. B and C, right? Yeah.
Yes.
Okay.
Done.
Cool. Done.
Okay. So complete your labs. Okay.
Yeah.
And tomorrow we start the HA, high availability.
Okay.
Okay.
Cool. Sure.
So complete all the labs.
Yep.
Done for today, and the remaining, the recording one, I have saved today. Okay, I said to the mail. Okay.
Okay.
And I also save the 2 days recording with you. Okay, it's take some time to upload on GoToTraining Cloud Data Store. Then it takes some time to compile and prepare. So it's take 2 to 3 hours. Sometime.
Okay.
Okay, so I will see you.
Okay, have a nice evening.
Thank you,
Okay.
Naveen. Yeah.
Okay, you're
Thank
welcome.
you, Ben.
Thank you. Bye.